Okay.
Hi, everybody. I'm Glenn Johnson. I'm at Johnson Space Center down in Houston, and I get to work with other engineers, astronauts, and the mentors to be able to come up with these different projects. So I'm excited to see what kind of things you guys are working on.
Awesome. And Nancy, will you
Hi,
introduce yourself?
yeah, I'm Nancy Hall. I'm one of the mentors. I mentor the students over, and I work at the NASA Glenn Research Center in Cleveland, Ohio. So I mentor the students in my region, which includes schools in Michigan, Minnesota, Wisconsin, Ohio, and parts of New York and Missouri.
Wow. And you also do experiments on this
Station.
space
Yep.
station. So that's pretty cool. All right. So now I want you, there's four of the young men here. I want you to introduce yourselves and then you can share if you have a PowerPoint or something.
We do have a PowerPoint. What do you want to introduce first? We can go this way.
Sure.
I'm not really in the picture, so
Yeah, you can get in the picture.
yeah.
Yeah,
Like,
you're gonna.
yeah, so working. I can sit here.
Yeah.
All right, so I'm Bryce,
Hi,
um,
Bryce.
and moving forward, I think I'm gonna be in charge of a lot of our like uh controlling the robot more digitally with our Arduinos or whatever we end up using.
Awesome.
Yeah, just introduce yourself and what
Um,
grade, and then yeah, go ahead.
I'm Zach. Am I in frame here? Yeah.
Yep.
So far on this project, I've been in charge of the self-writing system, and I've also done a lot of the CAD.
Awesome.
Okay, great.
I'm Parker, and so far I've been doing a lot of work on kind of our jumping mechanism.
Okay, Parker.
I'm William, and I've kind of just been helping out with building every so often. Um, I've also made some designs to help the locking mechanism of the self-writing mechanism.
Awesome. Okay. Thank
Nice.
you for working on us. All right, now you can share your screen if you want.
You know how to do that? You can do it.
Yes, it's
Oh,
working.
and we can
Seals.
present as well.
Yeah.
Yeah,
Yes, it's perfect.
that is perfect. You can control it, Parker.
Yeah. You want to introduce it?
Yeah. Um, this is, as the name suggests, it's our jumping robot, the stored energy aerial lunar surveyor.
Awesome.
Okay, I love that.
I like it
Stored
too.
energy and takes pictures. I think it's spacebar or click.
There we go.
Yes.
So for our project overview, our goal is to make a remote controlled jumping robot that can repeatedly take aerial photos of the lunar surface without physical intervention from astronauts, and hopefully get it to jump as close to 10 feet as we can on Earth without going over, so that can go pretty high on the moon.
Mhm. This is our research slide. We researched several potential designs, um, a lot of different propulsion options, especially. We kind of weighed it all together in a decision matrix, with the pros and cons. Um, and we also looked at a bunch of just other designs, like jumping robots that people had made in the past. Like there are actually competitive jumping robot teams. Um, and also Boston Dynamics made a really good jumping robot. Um, MIT designed one that I think was included in the slideshow. And so that was the research.
So bad.
So we've had quite a bit of designs we've made so far. We've made quite a few designs. So in the middle, that's sort of our only design on paper. Well, we have more, but that's like the only one that actually goes in depth. It's not just like we draw like a rough design of what we're gonna do and don't really label anything. On the left, that's an example of one of our 3D models, which we have quite a few. As you'll see later, most of the 3D models got printed out into parts for our robot. And you can't really see it anywhere, but we do have quite a few designs as well for our self-riding mechanism and the video.
You'll see some
Yeah.
designs for the
It's-
self-riding mechanism
It
later
is.
on.
We took inspiration from who made that robot?
This was the MIT robot, I think,
Right.
the one that was linked with the slideshow.
Yeah.
And it can like get up like that.
Although we did change our design. So
Yeah, that was our
it's
first
less
design.
inspired by that robot.
These are our first prototypes that we tried, like with the right self-riding mechanism, the jumping mechanism. As you can see on the right, the jumping mechanism kind of like broke because the spring we used was far too strong for just 3D printed material. So we're working on that to see we're getting better materials to make it like so it can actually survive a couple of jump tests. And the self-riding mechanism, we're working on like a way where it can just like we can like remote control it and like ride it on itself and not have to like go up to the robot and like move it manually. And then the self-riding base, the new model, we've changed that a couple of times. That's the latest one we have.
These were our first kind of prototypes. We didn't really, at this stage, we hadn't combined them together. That's our next slide. Basically, after making like those first prototypes, we kind of just took the elements together, like in some cases, literally just the 3D printed parts from them and combined them together to make this prototype. We're calling it like kind of a version 1.5 because it could do both functions. It could jump and self-right. But also it would break a lot because we had like the 3D printed components, which are fairly weak and they would often crack. So for our next prototype, we decided to use PVC pipes because like we wanted it to survive more tests.
Okay. Hey, could you guys give me some dimensions there? How tall is this thing?
This thing's about 6 inches tall.
6 inches tall. Okay.
6 inches tall. Each one of these legs, I believe, is about 2 inches.
Uh-huh.
I can get the actual model if you want to.
That's okay. Show me in a few minutes. Go ahead and continue with what you got there.
Okay. So this is the current version of our prototype.
Which legs did you fit this one?
Yeah, this is the current version of our prototype. Our first goal is to incorporate the motor into our design and then simplify it all, make it easier, and then so it's not hand powered. And then we're really working to make it stronger. And we've sort of revised our self-riding prototype, as you can see here. And instead now that just kind of slides down to self-ride it from like the top to the bottom.
Yeah, we have a video of how it works. This is just a video of one of our tests.
Very nice.
We
Now,
changed the
Yeah, that
design.
is very cool.
Yeah,
now
mainly-
I noticed you've got a pretty big motor on there. That looks like it's from maybe Vex. Is that right?
yeah, it is.
Okay. Keep going. I'm excited about what you're doing.
At this stage, we're trying to get everything driven from a single motor rather than have it be more complicated than it needs to be. And
Yeah.
so that's kind of, influenced the change in our design alongside the need to strengthen it.
Yeah, and that's probably not gonna be our final motor. It's just what we've had available in our classroom, so it's just what we've
Understand.
used as a base to start.
Mhm. Once Bryce, you want to do it?
Okay. So part of your idea is to have one motor that moves the legs so that it stands up, and at the same time, the it it compresses your spring. Is that right?
Yes,
Yeah.
that's right.
Very nice.
So, that first test or the self-writing we just showed you uses a small PVC pipe. I believe it's 1 inch in diameter. And then the second PVC is 2 inches in diameter. And this is where we're gonna put like all our components that we need. So like we're gonna have um like we're going to put the self-righting mechanism on the outside of this 2 inch PVC, and then we're gonna have like our battery, our like Arduino, our motor, all within this 2 inch PVC. And then in the small 1 inch PVC, we'll probably just have our jumping mechanism in the future.
Yeah, that's what we're looking forward, kind of immediately to our next prototype. And then after that, what we want to do with subsequent prototypes is upscale that so that instead of being like 6 inches or 8 inches, we want to purchase like a big spring and better components so that we can actually jump it like a matter of like feet, to like hopefully around 10 feet or below it. Because right now I think our highest test was like 18 inches. And we'll also put a camera on it at that stage. We've been looking at drone FPV cameras because they're like really tiny and high resolution. And also Bryce is gonna go coding at that stage as well.
And we're also gonna start looking into a way to insulate our robot since we're going with the spring. It's gonna need some sort of insulation to be able to survive the temperatures on the moon.
Okay.
Very nice.
Yep. The one thing I would say is I like the idea of you trying it small, making sure it works, and then upscaling. Just be careful when you upscale because I don't think it'll be that easy to find the exact components scaled up. And also, as you do this, check the weight and make sure I know you have the layout here, but make sure you distribute the weight correctly. Because if you have it too heavy on one side, that may hinder it as it's jumping or moving over.
Good comment. Um, I like what you're doing. I think this is terrific. I think one of your heaviest components right now is probably your PVC pipe. Do you have any other thoughts as to what you might be able to do there?
We could probably go with like a similar material that's lighter. Like I know there's very similar alternatives in like cardboard and stuff that we'll probably use on our larger prototypes.
You know,
We'll
that's
have
not a
to do
bad
the
idea.
testing.
One of the thoughts I had, and imagine if you use like one of those tall beer cans because
Oh,
it's
yeah.
because it's aluminum, right? you've got some real durability. However, as soon as you cut off a top or a bottom, um, you're going to have trouble with it being too flexible. If you can keep that rim, that'll help. Another thought is that you, in the same way that what do you call it? In the same way that like a paper drink cup, if you don't have a lid, it's really flimsy. But of course, as soon as you put the lid on, it's a lot more rigid. And I think you might be able to do something like that so that even if you cut off and just use the aluminum walls of it, you might be able to put caps on either side and gain a lot of your rigidity back. Does that make sense?
Yeah, I think that's a great idea.
Another thought that might be helpful, you might be able to use like a 1 liter bottle. And because it's transparent, it would make it easier for you to be able to place components inside and do some of your adjustments. I really like what you're doing. Do you have more slides yet?
I think we have one more slide.
I think we do, talking about like some of the challenges that we like are still trying to figure out.
Yeah. Show me that, but I want to go back to your video in a minute. Go ahead.
So like one of our biggest challenges right now is just finding a really simple and like reliable way to release the spring. That might be doable, and just finding the right motor that we're able to just sort of release without it maintaining like any force pulling it the other way.
Okay. Now, and what kind of have you guys looked at Spark Fun at all?
I think so.
When we were researching motors, we did.
Yeah, it was one of the places we were looking at getting motors from in the
Okay.
future.
And look on there. Not only do they have the like Arduino Unos and stuff like that, but they also have the motors. And for a lot of those components, they already have the computer code so that you don't have to come up with the code yourself. It'll already be there. Does that make sense?
Yeah.
Yeah.
And they'll also help you pairing up the camera for the kind of for the kind of computer you're getting. Okay.
Yeah.
This is really great. I got to stop for just a second. I'll be right back.
Yeah, how about you, Flo? You got any comments? I really like this. This is neat.
Yeah, I really liked it too. But what my main comment is, all those previous models that you have gone on to from your very first one to your current one, make sure you save them, and they should be part of your display when we do our critical design review at MSU. I want to see the progression of how your model has changed over time. Can you do that, team?
Yes, we can do that.
Okay, save your
Yeah,
models.
yeah, and one question, yeah, document it with pictures and stuff. And I guess my question is, how far along are you going to go with your current model before you start the other one? Because right now you showed that you're able to move it and everything. Are you going to try it? Do you have the components for the smaller one? You're going to test, see if it could jump, or are you at this point going to try to just make it taller or longer?
Our next step is to make our current prototype jump.
Okay.
Which Parker's been working on that, and he can tell you about it. How we're gonna do
Yeah,
that.
I've been working on a mechanism to kind of help in case like we end up going with a weaker motor that helps kind of gear it up a lot so it doesn't use much power to wind up the spring.
Okay.
It got taken apart on accident so that we don't have it currently, but I'm rebuilding it right now. And then yeah, we're just hopefully going to integrate that with our current prototype, and then also integrate it in future prototypes.
Okay.
Could you guys go back to that video for how it stands up again?
Yeah.
Yeah.
Wow, that's really cool. I like how you do that. Can you tell me a little bit about how it's moving? I think what I'm seeing is that the motor has the spring and it comes all the way down through the tube and then back up to the legs. Is that right?
Yeah.
Yeah.
That's just about how it works. On the CAD model, you can kind of see there's like a axle sticking out of the top. That's what the motor's connected to, and it like kind of within the tube there, it has a like spool that it winds the string onto. And so it pulls it through the tube, thereby pulling this the self-righting legs down the outside of the tube. Um,
I think that's really amazing.
yeah.
I like how you've done that. How how do you, are you expecting the legs to get back up every time that it jumps? How are you guys thinking of that?
We were gonna put rubber bands on it so that when the piston goes off, the spool it'll pull the spool and like undo all the string like pretty quickly. And then all that excess string will get pulled up by the rubber bands. And that will allow the self-righting mechanism to return to the top of the robot so that
Huh?
when it lands, it's pretty much guaranteed to land like kind of on its side in a way that we can ride it.
I think there's some real genius there. I think you guys got something really good going. Um, and okay, so here I see that the legs are just straight out. Is that how it was in your video? Is that right?
Yep.
Yes.
Okay. And I just couldn't remember it yet. Um, Now, and you say that you've gotten it to jump, what, 18 inches or so?
Yeah, that was on a previous prototype, but yes, that's about
Yeah.
our
We're
record.
hoping once we get this one to jump, since it's stronger, we'll be able to use a stronger spring, and so hopefully it'll be able to go quite a bit higher.
Okay. I hope so too. One of the biggest difficulties is probably weight. The lighter you can make it, the more likely you're going to get the kind of jump heights that you're looking for. Um, and so part of that question might be, do those legs that are sticking out, do they have to be metal?
Yeah. I think we could figure out some other material that's pretty close to the durability of metal, but a lot lighter.
And it might not be, huh? What if you kept it metal, but you made them just like a lot thinner and more like kind of a springy strand? Would that still work?
Yeah, that was kind of more so how it was like in the video from MIT earlier. I don't know if you remember that.
I do remember it a little bit now
Yes.
that you say it. Um, and here's one of those goofy things. You know those I've seen these head massagers. They're like kind of metal springy wires, and it kind of massages. It goes like this on your head. Have you guys seen those?
Okay, I
Yeah.
think so.
Yeah.
Yeah.
Okay, and what I'm thinking of, it's kind of like cat whiskers, right? In that they'll spring out. Normally they're in a straight out kind of position, and then one every once in a because they're very springy, they'll try to stay in that outright position, but they're fairly lightweight. And so I'm just thinking that you might be able to do just by lightening those up with more of a springy wire, that it might help you with that kind of thing. Okay. I really
Yeah.
like what you guys are doing. I think this is really smart. The way and being able to demonstrate some of that with your video, I think is terrific. Do you guys have something you could show us now?
Yeah, we have a few physical prototypes.
Excellent.
Um,
Let's stop sharing. Let's see what you got.
you can
Okay,
stop sharing it. This one you can present that. I'll grab the self frame.
Just grab like everything we have. Just in case.
Yeah, all of the previous ones as well.
Yeah.
Okay. Wow. Yeah, that's. Oh.
So this is here, let me angle it down a little. This is kind of the last jumping prototype that we have. And it's just hand powered right now, as you can see, but
Hold it up. Your camera's moving.
oh,
It is? Oh,
Yeah.
yeah, that's that.
It's doing the digital shift or something like that.
yeah, and it's definitely hard to release with just your hands, but
Oh, now it's frozen.
Does that?
and it's not that strong of a spring right now, just because we don't want
There
to
you
break
go.
our 3D model.
Oh yeah. No, do that again. Show me what you got there.
It's hard. It's hard to get a good release on it because of
I just put a little tab on it that you can hook
it.
inside there. Do any of you remember like those Lego like shooters you'd like push on the on like the back of the projectile and it would like
Yep.
unhook a hook and launch?
Yeah, very good.
We've got kind of a temporary trigger mechanism like that. Like if you push on this, it might go. I don't know. I actually haven't tested it,
Very good.
but yeah,
How,
it works about like that.
how do you think you want to activate it then?
That was one of the challenges, actually. Did you have anything in mind for how to activate it?
I think if we could get it a little better, we could maybe have like a little like tab or something that comes out of the bottom here, and then that we can like sort of like pull out on our own. That would kind of uncatch it.
Okay, so wait a minute. How is this? Do you have a notch on your shaft right now, or what do you have?
Yeah, like right here. You can see we have this little 3D printed piece that kind of creates this notch on
Okay.
our shaft.
And what is it catching on?
It's just catching on right now, it's just catching on like inside the base here. Just like right on the inside of the base, if you just kind of pull it to this.
Ah,
But
okay.
if we could like,
So you push it over to the side just a little bit,
yeah.
Yeah,
and then
yeah,
But
okay.
if we could,
yeah.
yeah, if we could design like a tab or something instead instead we push the tab in instead of pulling the piston to the side. And then we're able
All
to
right.
just
Okay, you guys are inventing it as you go, and I think that you're on a really good path. So consider right now you've just got a cylinder that goes around it, right?
yeah.
What
Yes.
if you make it so that one side is notched is a little bit wider, and it'll push it over to the opposite side as it goes up? Does that make sense?
Yeah.
I think so, yeah.
And what I mean is, so right now, a straight cylinder goes up, and if you push it to the side a little bit, it catches. So all you have to do, I think, is change that from being a circular cylinder and have some of it so that one side pushes it over, and then on the other side, if it goes up a little bit higher, it'll push it back the opposite direction, and that'll be your release mechanism.
Yeah. Okay.
Yeah.
And I think you guys are going to be able to kind of tweak that and make it really good. But good job, team. I think you've got something very different there.
Yeah.
Thank you.
Now right now you've got looks like a stick. a little dowel rod that's holding your spring in place. Is that correct?
Yes. Yeah.
Yeah.
Okay. And how do you want to go with that next? Is that going to stay this way, or what were you thinking of?
I think in the end, we'll hopefully have some sort of like cap there or something that we can kind of just slide in and like lock into place. So it stays kind
And
of in the uh like kind of like the shell of the robot.
right. And your string is going to have to go down through the center of that. Is that right?
Yeah.
Yes.
Okay. Um, all right. So I think what you want is on your upper side there is probably a lip so that the spring pushes up on the bottom of that lip. And that way you still have plenty of room for your spool and a string to go down through the center. Does that make sense?
Yeah.
Yes, that makes sense.
Yeah.
Okay. And part of why I'm asking, what kind of string do you want to use there?
We haven't thought that through a ton, but hopefully some string
Might have one.
that's kind of like sort of like a string, but it's got kind of the like sort of like it's kind of got like the like aspects of a wire, but it's still a string so that it's lighter. So it's
Do any
like
of you fish?
Yeah, I
I
was
want to see.
eyeballing like braided fishing line. They make some pretty strong ones. With
There.
that.
I think that's
Yeah.
the right answer. Don't use a monofilament. I think that a braided or a stranded fishing line might be your better answer there. Okay.
Okay.
And part of what I'm talking about is how stretchy it is. A monofilament is a lot more stretchy, and I think that you'd have problems with that. But I think if you use the braided, I think you'd have a much better string for it, and you'd get a lot more strength as for the diameter that you're going to look at. Does that make sense?
yep.
Yeah, that makes sense.
Now, what about your spool? What are you thinking about there? Are you planning to have two different spools, one for the legs and one for the spring?
Yeah, the diameter or the displacement of the piston will be different than the self-righting mechanism because here's this model. The self-righting needs to slide like basically over the entirety of the body for it to be like effective because if it's kind of halfway in the middle, there's a
Yeah.
chance that it'll like land in a way that we can't write it.
Yeah, and then we could just we could adjust the diameters of the two spools so that while rotating the same amount, they will cause different displacements.
Sure. Okay. I like what you're doing. Hold that up to the camera a little bit, would you? That's really cool. No, I look forward to how you guys want to work on this next. Lightweight is going to be, any weight that you've got is going to be kind of your enemy for this. But I think you guys are on a really good path. I've seen lots of geared motors that are pretty small, and they should be able to handle some of the forces that you're looking at.
Yeah.
Good job, team. Do you have any questions for us?
Not particular, I don't think, really.
All right.
Really, do you have any? No.
What do you think your next step is? How do you guys want to progress?
Immediately, our next step is to put this, like basically replace this plastic tube with just the inner part of this PVC, so get all of this stuck up in there so that we
Uh-huh.
can get a little bit of jumping action on this robot. And then after that, with our larger prototype, we're gonna try to integrate like a battery into the main body of it and anything else that we need so that we don't have like these trailing wires.
Very good. Okay, I mentioned a couple of things. I think like one of the tall beer cans, a 1 liter bottle, and stuff like that. They are pretty flimsy. So besides top and bottom caps, you might if it's needed, you might be able to do some structural support inside, but still keep it low weight. You may not need very much. It's just to keep it from twisting or something like that. Team, I like what you're doing. This is looking really smart. Good job, guys.
Thank you.
Thank you.
Thank you.
Yeah, I think
Yeah,
it
nice
looks
work.
awesome too. And if you look at that MIT robot, that was as light as can be. They got rid of anything that they didn't need. You know, it was like a skeleton of it. So see what you can get rid of, and use a material that has the structure, like Glenn's telling you, and still as light. And actually, you should look into materials and see what NASA could use, because they can use some materials that you might not have handy, but that would really make a difference in the weight, because the cost of sending it is expensive. So every ounce you can get rid of is really good. So really innovative. Nancy,
Okay.
you have some comments?
No, I thought it was real good. I was listening to the discussion and stuff, but real nice. Very,
Yeah.
very nice work.
I like how it writes itself. That was awesome. But yeah, take a close look at the jumping robot from MIT that you showed us and get rid of anything you don't absolutely need.
Yeah, yeah.
All
All
right.
right.
All right. And you can always send
Thanks,
us
guys.
questions. So thank you so much. And you have a wonderful Thanksgiving there and a great afternoon. It looks sunny there too. So
Yeah.
Yeah.
Thank you, guys.
Yes.
okay.
Excellent job, guys. I'll see you soon, I hope.
Thank you.
Okay, see ya.
All right.
Thank you.
Flo, is that
Thank
your
you.
last team?
Yes, that's for today.
Okay.
We're
Yeah, I'm
done.
about to, I got a whole bunch of biomedical teams I'm gonna be doing in about 5 minutes. Allie saw him last month, so she's okay. So I'm gonna see him this month because I had scheduled a meeting with them last month. So this is good timing.
Is that with Michael Dalmont?
Oh, no. This is with Malia Pryor. She has a biomedical class, so I'm gonna be doing